Next, equivalent resistance. When various resistances are connected in series and parallel, then how can we represent with a single equivalent resistance? So first we will take the series connection. Okay, so in series connection, it is going to be like this. Let us take n number of resistances. Okay. So what will be the voltage? Each of the voltage we will take as V1, V2 and so on till Vn. The current that is passing will be the same, which is I. Okay. Now you have to replace this with a single equivalent resistance R equivalent. Now what is the current passing through this? It is I. And what is the voltage across it? The voltage across this is going to be, if you take this entire voltage as V, don't forget the polarity, then here it is going to be V. So from KVL what we have, if you apply the Kirchhoff's voltage law, you get V is equal to V1 plus V2 plus so on till Vn. Okay. Now what is V? V you can write as I into R equivalent by Ohm's law. So I R equivalent is equal to, similarly you can apply Ohm's law to each of the resistances. So you're going to get I1 R1 plus I2 R2 plus so on till IN Rn. Then if you cancel out I, you're going to get R equivalent is equal to R1 plus R2 plus so on till Rn. That is simply the sum of resistances. Okay. So this is for series connection. Okay. Next, if you discuss the parallel connection. In parallel connection, the resistances, they are going to be connected like this. This is R1, R2 and so on till Rn. Right? Now the current that is flowing through this entire combination, if we take as V, and the voltage is V. Now we want to represent with an equivalent resistance R equivalent. Then current through this will be I and voltage will be V. So the voltage across each of them will be same. What about the currents? The currents will be different. I1, I2 and so on till IN you can take. Okay. Now from KCL, if you apply KCL, then what you're going to get in this circuit, I is equal to I1 plus I2 plus so on till IN. Now I you can write in terms of equivalent resistance. How you can write? Using the same Ohm's law. V by R equivalent is equal to I1 also you can write in terms of the voltage using Ohm's law. So you're going to get V by R1 plus V by R2 plus so on till V by Rn. Okay. So then you can see that the reciprocal of the equivalent resistance is equal to sum of the reciprocal of all of the resistances. Okay. So this is the relationship. This is how you get the equivalent resistance for a parallel connection. So that was about series and parallel connection of resistances. Two more important things that you need to know that will help you for easier and faster analysis is, one, when you have two resistances in parallel. Okay, so that means R1, R2. Then how do you write the equivalent resistance? So R equivalent is given by R1, R2 divided by R1 plus R2. The product of the two resistances divided by the sum. This is nothing but you just get it from the original expression. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So 1 by R equivalent is equal to what? R1 plus R2 by R1 R2. So R equivalent you will get this expression. It is important to remember this expression. Okay, it is easier. It will make things faster and easier. Okay. The second thing you need to know, when n number of resistances, equal resistances are connected in series and parallel. Okay. Equal resistances in series and parallel connection. Okay, so first if you consider series connection, so equal resistors, let us say there are n number of equal resistors, okay, n number of them, then R equivalent will be simply n times R, because you are adding R n number of times. Okay, and what about parallel connection? So n number of parallel resistors. Okay, same n number. Then you're going to get R equivalent is equal to R divided by n. Okay, because the reciprocals you are adding n number of times, so 1 by R equivalent you will get n times 1 by R, so R equivalent is equal to R by n. Okay, so these are the 2 points that you need to remember, which will make things easier. Okay.